Hello, math champions. You would have heard about this word called algebra. But before we start learning about anything about algebra, we'll understand why this came into existence. Okay, according to me, why this came into existence is one thing is when mathematicians started seeing some pattern. Okay, and then they started generalizing it. They wanted to represent it in some way. Okay, represent it in some way. That is when they started using it. That is one thing. And another situation is when there was something unknown. Okay, and other one aspect is unknown, some parts were known, like something was known. And using this information they wanted to find out what is the unknown. Okay, find out what is unknown. So these are the situations that, according to me, algebra is very, very useful. I'll explain what I'm meaning here. I'm meaning here, for example, let's say, um, every time I am, let's say two people are there. Okay, let's say two people are there, and they're siblings. Okay, they're siblings, and this person is 5 years old, and this person is 2 years old. Say after 1 year, what happens? This person becomes 6 year old, this person becomes 3 year old, right? And after another year, this person becomes 7 years old and this person becomes 4 years old. Whatever be the case, if you see the difference between them is always three, right? So that means there is a pattern here, right? There is a certain pattern which will continue to happen always. Though their ages are not same, but there is a pattern. What is the pattern? The difference between their ages is always three. So there's a pattern here. Now they want to generalize this aspect. So what they can say is, let's say these two people are here like this, and so instead of saying this person is 5 years and this 2 years, I'll say this person is X years, then surely this person is x minus 3 because always the difference is 3, right? So this person is 3 years lesser. So we were able to generalize it and represent saying the this person is x means this person is x minus 3. Or you can also say that instead if I say this, if I choose this, the younger person as X, then this person will be 3 years older. So this will be X plus 3. So this is one scenario where algebra is used, okay, according to me. And the second scenario is when we don't know certain things, okay, means let's say totally the amount of income that I have, like in every month, my salary is 10,000, let's say. Okay, and there is some expenses and there is some savings. Okay, after my expenses I do some savings. Okay, so this month I was able to save 3,000. Okay, so my savings is 3,000 because I don't know how much I spent. I lose track of how much I spent. But at the end of the month, I'm left with 3,000. And I know in the beginning of the month, my salary was 10,000. So in this case, there is one unknown. How much I spent, that is, I don't know. There is a known factor also called saving, right? I know what is left out with me. So, and I also know certain things called, okay, my salary was in the beginning this much. One thing I know for sure is this expense and saving, if I add it together, it should come to be 10,000 because that is the total amount I had. That much only I could have spent, right? And let's say next month I was left with 2,000 only, though I got 10,000 in the beginning of the month. So how much was the expense here? If you see here, one thing was unknown, right? So whenever there's an unknown, we write that place as X. And we know that expense, so X will mean expense and the saving is 3,000. So X plus 3,000 is 10,000. Similarly, here also X plus 2,000 is 10,000. What does it mean here is if we go by this, the value of X will be 7,000, isn't it? But the value here in this scenario, the second month, the value of X would be 8,000. What do we see here? X is something we don't know, but it is also the thing, it is the value can change, keep changing. So value can keep changing. So this, because it can keep changing, it is called as a variable. This is the situation. These are the two situations as per me. Algebra is useful, right? And you also in your general life, daily life, you can use algebra in these ways, right? When you have a pattern, you can generalize it and represent it, and that is how you will get formulas, right? Formulas, right? For example, you must have heard, the area of a rectangle. Area of a rectangle is length times breadth. Area of a square is side times type. How have they come up with these formulas? Because they have seen a pattern, they have generalized it, and they have come up with a formula. That means this can be true for all the ways. Whatever be the value of L, whatever be the value of B, these values can keep changing. They are variable. Variable means changing. The values can keep changing, but then, however, if you multiply the length and breadth, you will always get the area. So this pattern, this generalized pattern will never change. So that is what we mean by this. And that is how algebra is useful. Now what we are going to do is we are going to see some sentences here and, and translate these sentences to, what is it? Mathematical, algebraic expressions, we call it as. Okay, so that you can be clear about how you can translate a particular situation or a sentence, or a sentence in a problem given to you, or in these kind of situations, how you can change that into an algebraic equation and understand and solve them. Okay, so sum means it is addition. If you see, I'll be going word by word. The sum means addition. Sum of X and 2. See, if I see X and 2, one by one I'm writing. So you should see how I'm writing it. T, okay, T divided by 8. So I can also write as T divided by 8. I can write like this also. The product of 9 and M. 9 and M. Subtract 5. Subtract 5. Okay, subtract 5 from what? From means it should be the previous number. So this will be here. Subtract 5 from C. Okay, combine means I'm going to add. So plus Y and 7. Y and 7. Correct? Then 3 sevenths. 3 sevenths. Of means multiplication. 3 sevenths of H. So when I simplify this, I can write as 3 times H is 3H over a 7. I can write like this also. 3 multiplied by D. 3 multiplied by D. Okay. I hope you are able to follow all these things, right? Okay. Let's see. Is there any other further things that I can help you with? Yes. Okay. So 1/4 means 1/4 added to N. B decreased by means this is reducing. This is reducing means this should be before in the subtraction. Decrease means subtraction. So decrease by 10. Okay. See, there's a difference here. Subtract 5 from C. Means C will be before. But B is decreased by. Means B has values decreased. For example, 7 is decreased by 3 will give you 4, isn't it? So 7, when you decrease, let's say 7 apples was there, you decrease or remove 3 apples, you get 4, right? So that is what the meaning we are sort of talking about here. 1/2 of K. 1/2. 1/2 means this one. Of means multiplied by K. Okay. So this is how we will write, we will translate all of these things into algebraic phrases. Okay. Okay, let's do some few more things here. and let's see if you're able to do it. I would highly encourage you to pause the video, look at these questions, try to do on your own, and then compare your questions with mine. Right? Compare your answers with mine. Okay, two nines, two nines. Off means multiplied by h. G reduced by 1. Okay, the quotient means the answer, right? The answer of division. Okay, quotient. Okay, so means quotient means they have not given the answer here. The square of r, quotient means basically division, isn't it? So division, division. Okay, division, quotient. Square of r means r square, and 6 means divide by 6. Okay, quotient of r square by 6. Here we are assuming that whatever is coming in the beginning is the dividend. Okay, we are assuming that, though it is not very clear to us here in this aspect. Okay, combine means addition. Cube of k means k cube, and 27. Y raised to the fourth power. Y is raised to the fourth power. 10 multiplied by m. Okay, one half of the cube of k. Of is here, cube of k cube. I hope you're understanding how I'm changing every sentence into a algebraic expression, right? If, for example, if they have not given, like say, g is reduced by k, instead of that, if they're saying a number reduced by 1. If they give like this, now you can give this a number, any letter for this number. Because why we are using letters? Because numbers, they have a fixed value. They cannot change in value. But then a letter, when you're using, it can change in value. That is what I was explaining, that when we are saying some unknown, it can vary in value. So we'll give an alphabet for this. So in this place, I can give x reduced by 1. And you will be wondering, how come I got x minus 1 here and z minus 1 here? Is it same or is it different? It is same in one sense. What? The concept is same. Some number is there and you're subtracting 1 from that. That's the same concept here. Let it be this or this. Only thing is, here they've already mentioned that number's name is G. And here, because they have not mentioned, I am taking any alphabet. Why am I choosing always X? I can always choose A also, B also. That is up to you. Okay. It's not necessary that you have to use X only. Okay. Some alphabet, that is a convention that we use a small letter alphabet. That's all. Okay. Math champions, I hope you have understood all of these things and you are enjoying learning mathematics. I'll see you with more about algebra in the next coming videos. Until then, bye-bye.